Now question number 16. In this question, this is totally mathematics part. And also this MCQ type. Starting at time t equals to 0 from the origin, with a speed of 1 meter per second, a particle follows a two-dimensional trajectory in the xy plane so that its coordinates are related by the equation of y equals to x square by 2. Y equals to x square by 2. That is the given relation. Then x and y are the components of its acceleration along x and y directions are ax comma ay. These are the components of accelerations. Here he had given some conditions, so that we are verifying is it correct or not. So for that purpose, by using this equation we are finding first velocity and also acceleration, because we are verifying velocity and acceleration, both conditions in this we are verifying. First one velocity and again one acceleration. So for that purpose, first we go to y. For example, here y and x, how it is? Y equal to 4 here, y equal to x square. That represents what? One parabola equation. So from this, what we are writing? This is one parabola only. This is one parabola. So it comes like this. X two components, y one component. So it is parallel to, it is like this. For example, if it is x square equal to, if it is y square equal to 4x, it is along the x-axis, like that comes. That mathematics will know. So this is my origin. And also he had given velocity along the x direction. Velocity along the x direction is 1 meter per second he had given. And this is my origin. So that is the condition. At time t equals to 0, that is the position of the particle. So first we are finding velocity. First we are finding velocity. How we are getting velocity? Here displacement given. Y belongs to along y axis, x belongs to along x axis. So we are taking dy by dt. I am taking y equal to x square by 2. You take this first equation. I am differentiating both sides with respect to time. Then dy by dt, that equals to differentiation of x square by 2 with respect to t. Further, dy by dt, rate of change of displacement is called velocity. Y means what? Along y direction. So this I am taking as vy. Similarly, 1 by 2 is coefficient comes to this side. Now what is the remaining part? Differentiation of x square with respect to t. So this what I am writing now? This is like differentiation of x power n. So n into x power n minus 1. That formula we know. So what is the formula here? Differentiation of x power n with respect to t. What is the formula? N into x power n minus 1 into dx by dt. So that formula you apply. Then what I am getting here? Vy equals to 1 by 2 into x power 2 minus 1. X power 2 minus 1 is 1. So 2x into dx by dt. That formula I am applying. Now I am 2 to cancel. Finally what I am getting? Vy. Vy that equals to, so first you take dy by dt equation. Finally we are writing that this dy by dt as it is you take. In the last moment we are applying because here one equation comes. Dy by dt that equals to x into, but the dx by dt, rate of change of displacement is called velocity, but x direction. So what I am taking here? Vx. This is my first equation. So here also later write Vx. You write dx by dt as it is. Dx by dt. This I am taking first equation. Now you apply concept. Rate of change of displacement is called velocity. Now you apply that concept. Then what happens? This implies rate of change of displacement is called velocity along y direction. So Vy I am taking, that equals to x into rate of change of displacement velocity along x direction. So Vx I am taking. This is my equation number 2. Again I am taking first equation. What is the first one? dy by dt, that equals to x into dx by dt. Again you take differentiation both sides. Then what happens? This implies differentiation of dy by dt with respect to t, that equals to x into differentiation of x into dx by dt with respect to t. How it is? Differentiation of uv, u into dv by dx plus v into du by dx. One formula is there. That formula again you apply here. Then what happens here? This implies differentiation of dy by dt with respect to t. That what we are writing? Second differentiation, d2y by dt2. d2y by dt2, that equals to, what is the formula here? This is the formula. What is the formula? Differentiation of uv with respect to x, u into dv by dx plus v into du by dx. That mathematics formula we know. That formula we are applying in this case. So this becomes u and this becomes v. Then what happens? d2y by dt2. This implies x into differentiation of dx by dt with respect to t, u into dv by dx plus v into du by dx plus dx by dt into differentiation of x with respect to t. Again, differentiation of x with respect to t, v into du by dx, that formula. So this formula we have applied in this. This is d2y by dt2, that equals to x into dx by dt with respect to t means what? Second differentiation. So d2x by dt2 again plus dx by dt into dx by dt. I am writing as dx by dt whole square. So this is my acceleration condition. Now we go to acceleration condition. Then if y is the displacement, dy by dt is rate of change of displacement, that is called velocity. Again differentiation. Rate of change of velocity is called acceleration. So second differentiation of displacement belongs to acceleration. So this I am writing as ay along y axis. Again x into, that also acceleration along x axis. So ax square plus dx by dt means rate of change of displacement along x direction. So velocity. So vx square. This is my equation. Here all options given belongs to velocity and acceleration only. We had got. Now you apply what are the given conditions and check that once. Is it correct or not? So what you are given first one? First one, ax equal to 1 meter per second square implies that when the particle is at the origin, ay equal to 1 meter per second square. So what you are given? First one. What you are given? Ax equal to 1 meter per second square implies that when the particle at the origin means x and y coordinate 0. Ay equal to 1 meter per second square. Ay equals to 1 meter per second square. This is one question. We are verifying is it correct or not. So that is my first question. Okay, now you go to Ax. Acceleration conditions you take. So third equation you take. 3 implies Ay equals to, at the origin x equal to 0 happens. So 0 into Ax square. Velocity along x direction already given 1 meter per second square. 1 square. So finally what happened? Ay equal to 0 into something? 0 plus 1. 1 meter per second square. So first one correct only. First one correct only. Second one. If Ax equal to 0, if Ax equal to 0, all time, if Ax equal to 0, all time, Ay equals to 1 meter per second square. That is another condition. That is another condition. So here Ax equal to 0 given. Then what we are finding? Ay value finding. So Ax Ay relation. Now you go to second one. Now you go to second one. What is the second one? Now only I told you. Okay. Now write. Second one. B. Ax equal to 0 implies Ay equal to 1 meter per second square at all times. At all times. So this is our second question. Once you check is it correct or not. So what we are writing? Ax equal to 0 writing. Again what we are writing? Previously only this already came. So here what we are writing? If we write here Ax equal to 0, Ay equal to 1 meter per second square getting only. So that always correct only in all times. Not only at the origin, at any time also it happens. Because V value constant. That is V value constant. And Ax value 0 only. Ax value 0 only. If it is Ax equal to 0, what happens? For example, origin means x equal to 0 happens. For example, I am going to 1, 2. X value 1 only, but Ax equal to 0 now. So what happens? You take third equation. In the third equation, 3 implies Ay equals to, at the origin means x equal to 0. Not, for example, I am taking 2, 4 point, x equal to 2 only, but here Ax equal to 0, then what happens? X at any value, Ax 0, again this value 1 only. So, Ay equal to 1 meter per second square. If Ax equal to 0 happens, not only at the origin, at any point also, Ay value 1 meter per second square happens. So, that is the question. Next, third point. Third point, C. Third point. What is the third point, C? At time t equal to 0, the particle velocity always x direction. At time equals to 0, particle velocity always x direction. So we are taking velocity concept. We are taking velocity concept. What given? At t equals to 0, the particle's velocity, along x direction, So that is given. Now you go to question number C. So what is the velocity in x direction? 1 meter per second. What is the velocity? 1 meter per second. That is the value. Now you go to C. Velocity condition you take. Vy, that equals to, here you write t equals to 0. In the velocity what happens? If t equals to 0, at the origin also it is moving with what happens? Always particle moving x direction, not only from the origin. This is not from mathematics. Here already told, particle always moving x direction only with 1 meter per second. So from the origin only it is like that. So the correct one. Otherwise once we check here, Vy equals to x into Vx. Origin means 0 only, Vx equal to 1. Then what is the velocity? This implies velocity equals to 0 along y direction. So particle having only at x direction, at the origin. At the origin 1 meter per second only, x direction. Y direction velocity 0. That is the concept. At the origin means initial. Correct one. Next, d bit. Now d. What is the d1? Ax equal to 0 implies that Ax equal to 0 implies that at t equal to 1 second, the angle between the particle velocity with x-axis is 45 degrees. That is the d bit. What is the d bit? If Ax equal to 0 implies that at t equal to 1 second, the angle between the particle velocity with x-axis is 45 degrees. That we are showing. So what you had given acceleration along x direction 0 given. At 1 second, these two are the conditions you apply. You take acceleration. So what is the here? Third equation 3 implies what is the Ax value? 0 and time at 1 second. What is the Vx value? 1, that always 1 only along x direction. At origin also 1, at any point also 1 you had given. So what happens now? Ay equals to Ax equal to 0. So x into 0 square plus 1. Finally what I am getting? Ay 1 meter per second square. 1 meter per second square. Now what I am finding? Vy finding. What is the formula for V? U plus Ad formula I am applying. A means along x-ray y direction acceleration. Initially, already in the previous case only came. x equal to 0, 0 and something 0. Initially, along y direction, no velocity at the origin. So, initial velocity 0 only. So, Vy equals to 0 plus, what is the Ay? 1. Here, what is the time condition? 1. Finally, what I am getting? Vy? 1 meter per second. Now, what is asking? At 1 second, it is making 45 degrees with x axis. That is asking. What is the formula for tan theta? You go to concept. For example, I am taking A equals to A1I plus A2j, one vector. This x axis and x dash and y dash. A1I means like this comes. This is one vector, A vector. What are the components? One is A1 and another is A2. A1I means x vector. Along x direction component vector. Y direction component vector A2j. Addition of vectors A1I plus A2j. So this angle I want to find. What is the tan theta? A2 by A1. A2 by A1. If it is a displacement vector, S1 plus S2. If it is a velocity vector, V1 plus V2. If it is an acceleration vector, A1 plus A2, like that. Here we want to find the velocity vector. So here what happens? Velocity vector means V equals to V1I plus V2j happens. Same like this only. For example, here at 1 second, what is the velocity vector? V1I plus V2j. What are the velocities? Vxi plus Vyj. 1 means x, like that. In the x direction, 1 only. Y direction also we had got 1 only, at 1 second only, not initial. Initial 0. So what is my final velocity vector? I plus j. What is the form of a tan theta? A2 by A1. J component by I component. J component also 1, I component also 1. I am getting 1. Now you write this as tan theta equals to tan 45 degrees. Tan 45 value 1. So theta equals to 45 degrees. So you have given all ABCD options correct only in this question. This is about this question.